Every generative AI system you interact with, ChatGPT, Claude, Gemini, is built on 3 critical layers working in perfect harmony. Understanding these layers reveals exactly how AI actually works and why some systems outperform others. Let's break down the architecture that powers modern AI. The first foundational layer is data. This is the raw material that makes everything possible. Generative AI systems are trained on massive datasets containing billions of text samples, images, code snippets, and other information. The quality and diversity of this data directly determines the model's capabilities. For example, if you train an AI on biased data, it inherits those biases. If you train it on high-quality, diverse information, it produces better. Major AI labs invest billions acquiring, cleaning, and organizing training data. This layer is invisible to users, but it's absolutely foundational. Without quality data, no amount of computing power can save you. Think of it as the soil. You can't grow a strong tree without healthy ground beneath it. The second layer is model architecture, the mathematical framework that actually learns from that data. This is where transformer neural networks come in. Transformers, introduced in 2017, revolutionized AI by introducing attention mechanisms. These mechanisms allow AI systems to understand relationships between different pieces of information. Essentially, the model learns patterns and weights connections between concepts. During training, billions of parameters, mathematical weights are adjusted to predict the next word, next image, or next piece of information. This layer is like the blueprint of a building. The architecture determines how efficiently the AI can learn, how fast it runs, and what it can ultimately accomplish. Companies like OpenAI, Google, and Anthropic are constantly innovating on architecture, making models faster, smarter, and more efficient. A well-designed architecture can achieve the same results with far fewer parameters, reducing costs significantly. The third foundational layer is alignment and fine-tuning. A model trained purely on raw data produces unpredictable outputs, so developers use techniques like reinforcement learning from human feedback, or RLHF, to align the model with human values and intentions. This involves human raters evaluating model outputs, training the system to prefer helpful, harmless, and honest responses. Fine-tuning also happens here, adapting the base model for specific tasks or industries. A legal AI needs different fine-tuning than a medical AI. This layer is where raw capability becomes usable intelligence. It's the difference between a powerful engine and a drivable car. Without proper alignment, even brilliant AI systems can be unsafe or unreliable. This is why major labs spend significant resources on safety, ethics, and quality assurance. As AI becomes more powerful, this layer becomes increasingly critical. Understanding these 3 layers explains current AI capabilities and limitations. If an AI system underperforms, you can usually trace it back to one of these layers. Insufficient data, Layer 1 problem. Inefficient architecture, Layer 2 problem. Poor user experience, Layer 3 alignment issue. This framework also helps predict where AI development is heading. Companies are investing in better data curation, more efficient architectures, and superior alignment techniques. The future of AI won't come from one breakthrough. It'll come from incremental improvements across all 3 layers. Recognizing this architecture is your key to understanding AI news, evaluating AI companies, and making informed predictions about what's coming next. If you found this breakdown helpful, subscribe to stay ahead of AI developments. Hit the like button to support this channel, and comment below, which of these 3 layers do you think is the biggest bottleneck in AI right now? Let's discuss in the comments.